Hi everybody, and welcome back to another episode of Magnificent Math with Mrs. Murray. Bum, ba, da, bum. Today we're going to be looking at solving systems of equations. This time we're going to be doing it algebraically, which means that we should theoretically be able to solve everything without the use of actually graphing these with technology. So there's two ways that we can solve algebraically, and you should recall from grade 10, they are substitution and elimination. So basically what's happening in substitution is that we're isolating for one variable, and then we're going to substitute that into the other equation, and then determine the values of x and y. And then when we eliminate, obviously we're going to work towards eliminating one of the variables so that the equation is now written with only x or only y. Once we determine the value of x or y, then we'll substitute that into the original equation to find the other value that we're looking for. So, in the first example, what we're going to do is we're going to solve this system, and I'm just going to show you how to solve it through substitution. Okay, so you can use elimination. Some people prefer to use substitution over elimination. Some questions will specifically ask you to solve one way, so just watch out for that, but whatever way you want to solve it is typically fine unless it's specified. So first thing that we're going to do is rearrange this first equation so that y is equal to 5x minus 10. So I've just moved the y over to this side and brought the 10 over to that side. And then what I'm going to do is I'm going to take this value here, so right here, and I'm going to substitute that in for this y right here in that second equation. Okay, so this is that next step here. So I've substituted 5x minus 10 in for y, and then I'm going to solve for x. As I do the math and do the algebra, what happens is that I get a quadratic equation here. Solving that quadratic, so two numbers that multiply to 20 and add up to -9 are x equal to -4 and -5. Solving for that, I'm going to find that x is equal to 4 or x is equal to 5. Okay, so a lot of this is just reviewing some of the concepts that we've already previously worked with. But from here, we need to figure out what our y values are that match with this value for x. So to do that, what I'm going to do is determine when x equals 4. So I'm just going to substitute the value of 4 in for x into either one of these equations. Why did I choose this equation? I chose it because it's a little less complex than the second equation. I need to do the same thing for when x equal to 5. So I find out that y equals 15. My two solutions then are 4 and 10, and 5 and 15. So when x is 4, y equals 10. When x is 5, y equals 15. And that's it. If you wanted to verify, you could obviously take these and substitute them back into the original equations, but we are not going to spend some time verifying. Our next example, we have a quadratic equation. So this time we have two quadratics, and this time I'm going to use elimination to solve this. Okay, so first thing that I'm going to do is I'm going to label these 1 and 2, just so that when I'm talking, you know which one I'm talking about. And what I can see is that both of the y variables have no coefficient in front of, they have a coefficient of 1 in front of them, okay? So the coefficients are equal. So what I'm going to do is I'm going to work to eliminate those. Now I need to ask myself, how can I eliminate these two values? And the correct answer to that is if I take this equation number 2 and subtract the first equation from it, you're going to see that I have a negative y minus negative y. That is really saying negative y plus positive y. So if we subtract the first equation, what we end up with is 3x squared. 4x minus x becomes 5x. Our y's are eliminated now. Then we have 4 minus 2, which gives us 2. We're now going to try and solve for x, so we move the 2 over to give us a quadratic equation. Because there's no common factor and this has a coefficient, we have to factor through decomposition. So we multiply 3 by -2 to give us -6. So now we need two numbers that multiply to -6, add to 5. Those two values are +6 -1. So we've just decomposed this 5x. We've rewritten it as 6x minus x. And then we factor by grouping. So we group these first two terms together and the second two terms together. Take out a common factor from those first two terms. We're left with 3x multiplied by x plus 2. Take out a common factor here, which is -1, and we're left with x plus 2, which means that our two factors are 3x minus 1 and x plus 2, giving us values of x equal to 1 over 3 and -2. Now we need to figure out what our y values are. So just like in example 1, we need to think about when x is -2. So we'll substitute x equal to -2 and solve for y, and we should find that y equals 12. So therefore, one solution is x equal to -2, y equal to 12. Then we need to figure out when x equals -1/3. So I've just shown here how we substituted in. I haven't shown you all the math just for the sake of running out of space, but it ends up with y equal to -2. So our solution would be, not showing up apparently. So it would be x is equal to 1/3, y is equal to -2. In the last example, we're given a word problem. So Terry's hitting the baseball, and this is the path that it's traveling on. Ruth is in the outfield, and she's going to run towards the ball and jump to try and catch it. This should say catch, not cat. Her jump is modeled by this equation. So in both equations, x is the horizontal distance from home plate, and h is the height of the ball. So solve the system algebraically, round your answer to the nearest hundredth. So basically, Terry's hitting the ball, Ruth is running towards the ball, and she's going to jump up and catch it. Obviously, we want to know at what height and at what height and horizontal distance away from the home plate is the ball caught. So our two equations that we'll work with are these. Right off the bat, we can see that h is equal to this, and it's also equal to this. So what we can do is substitute and set those two equations equal to one another. After we set them equal to one another, we rearrange, and we basically put all of the x variables on one side. Basically what we're doing here is we're trying to form a quadratic. Okay, this is a quadratic. I don't want to try factor it. It's a decimal number. It's pretty impossible to factor it without using a calculator, so we're going to use our friendly quadratic formula. Substitute our values for b, a, and c into the quadratic formula using your calculator, and you'll end up with x equal to 22.15 meters or x equal to 18.96. Now, that's the horizontal distance from home plate. Now we need to figure out what h is, or y. And so in order to do that, we're going to substitute x into this equation because it's simpler to work with for both of these distances. When we do that, I'm not showing all the work for it, but when we do that, we find out that at a horizontal distance of 22.15 meters away from home plate, they would catch the ball at a height of -4.6 meters, and at a distance of 18.96 meters away from home plate, they would catch the ball at a height of 1.97 meters. Now, if we think logically about this, is it possible for someone to catch the ball at a height of -4.6 meters? No. Therefore, the only possible solution is this one right here. So, the ball was caught at a distance of 18.96 meters away from home plate at a height of 1.97. So, that's 8.2. You're either going to use elimination or substitution. Factoring is important in this one, so you need to know how to factor just standard quadratics. You need to know how to factor decomposition, and you need to know how to use the quadratic formula. So that's all that I have for you tonight, and we'll see you tomorrow in class.